Hi everyone, in this video I will talk about economics of pollution control. I will talk about different types of pollutants, the pollution costs, and how to find the efficient level of pollution according to pollution damage costs and abatement costs. Then in the last section I will talk about quantity-based policy instruments to control pollution. First, the types of pollution. So we often see that there are two different types of pollution. The first one are called stock pollutants. So for those kind of pollutants, the environment cannot absorb or hardly to absorb. For example, the plastic, the heavy metals, the synthetic chemicals. And for the second type of pollution, we call them found pollutants. So for this type of pollutants, the environment can absorb. For example, the organic waste, the kitchen waste, the carbon dioxide. And also, based on the zone of influence, we can see there are local pollution, there are regional pollution, surface pollution, global pollution. The water pollution is often called the global pollution. The ocean pollution is often called the global pollution, and also the air pollution is often called the global pollution. So my question is, what is the efficient level of pollution? As I always talk, the pollution is bad, it's very harmful for human health, for animals, for our ecosystem, right? So what I want to say is that there is a trade-off between the damage people or animal or our ecosystem experience and the costs of reducing emission abatement. Reducing emission or reducing pollution reduces the damage that people suffer from environmental pollution, right? But on the other hand, we input so much costs to reduce emission. It takes the resources away that could be used in some other ways. So in the second video of this course, I remember I talked about this graph, right? So from this graph, we know the maximum net benefits are achieved at this level of abatement. So what does this mean? That means the maximum social net benefits are achieved not at the zero pollution level. So at the zero pollution level, that means we need to input so much costs to control the pollution, to abate the pollution. So even though at zero pollution, the total benefits would be extremely large. So for example, when there is zero pollution, that means the abatement quantity would be large. For example, here, so the corresponding total benefits would also be very large. But at the same time, we need to input so much total costs to control the pollution, to abate the pollution. That means the difference between the total benefits and the total costs would be even minimized. That's what we want as from the view of society. So what we want is to maximize the net benefits, maximize the net difference between total benefits and total costs at this level. So in this video, we will compare those two costs. First, the costs from damage caused by pollution. Second, the costs of pollution control. So from the view of cost effectiveness, we need to minimize the sum of those two costs. We need to find a specific level of pollution to minimize the sum of damage costs and the sum of abatement costs. We would start from the damage cost part. In general, the greater the pollution, the greater the damage it produces. So I think this one is very easy to understand, right? The marginal damage is defined as additional damage caused by an additional unit of emission. So from the marginal damage function, we see there is a relationship between the quantity of emissions and the damage caused by emissions, because the greater the pollution, the greater the damage it produces. We see that the relationship between the emission and the damage caused by one more emission is positive. For example, when the red line represents the marginal damage curve. So as we can see from this graph, when the emission increases, the marginal damage also increases. So this line tells us that there is a positive relationship between the marginal damage and quantity of emissions. And the area below the marginal damage curve but above the x-axis, A, we define here as A. The area A is the total damage costs caused by pollution. And when we move to the abatement costs part, abatement costs are the costs of reducing the quantity of pollutants being emitted into the environment. It is very easy to understand, and the marginal abatement cost is defined as additional costs of achieving an additional unit of decrease in the unit of emission. So that means the relationship between the quantity of emissions and the marginal abatement cost is negative. So keep in your mind, the relationship between MAC and emission is negative, but the relationship between MD is marginal damage, and emission is positive to make the difference between those two curves. So because we have this negative relationship, the MAC curve, marginal abatement cost curve, is downward sloping. So at the right end, when the emission is maximized, we see the marginal abatement cost is very small. That means the additional cost of achieving an additional unit decrease in the level of emission is very cheap, is very low. However, the higher the emission reduction, the emission reduction, the less the pollution, the greater the marginal abatement costs. So I think those two relationships are quite clear from this blue line curve. So from this blue curve, we start from the right side. At the maximum level of emission, the MAC is very small. But when we reduce more pollution, the MAC becomes larger. For the MD curve, for the red curve, we start from the left-hand side. So when the emission is small, the marginal damage is also very small. When emission becomes larger, the marginal damage also becomes larger. So it is very important for you to make the difference between those two curves. For the red curve, we start from left-hand side. From the blue curve, we can start to analyze from the right-hand side. It would be much easier for you to understand. So the blue curve represents the marginal abatement cost. The area below the blue curve but above the x-axis is defined as the total abatement cost. is defined as the total abatement cost. So in this graph, the total abatement cost is B, is area B. The total damage cost is area A. So let's move to this graph. Actually, this graph, those two lines, the green line, the red line, are exactly same as those two lines. The MAC is downward sloping, the MD is upward sloping. So here it is exactly same. So from the view of society, no matter which level of emission, no matter at which level of emission, it would have two kinds of costs. The first one is called total damage cost, and the second one is total abatement cost. So the society would always want to minimize the sum of those two costs, right? So that means the society would want to choose a level of pollution that minimizes the area under the MAC curve and under the MD curve. So from this graph, E star is the choice of level of pollution to minimize the sum of those two costs. We see that at E star, the area under the MAC curve is this red area, and the area under the marginal damage cost curve is this yellow area. So the sum of those two costs, we can say it is minimized. If you don't believe it, we can choose another level of pollution. So for example, if we are going to pollute at this level, at this specific level, then the area under marginal damage cost curve would be this area, this very big area C, and the area under the marginal abatement cost curve would be this area with small triangle area D. It is very clear or simple to summarize that the sum of C and D would be much greater than the sum of yellow and red area that are right. Suppose we are going to pollute much less. So that means at the same amount of production, we need to abate much more. Then the abatement, suppose here is our pollution level, then the abatement cost would be much larger, would be the area under the marginal abatement cost curve. And here I define this area as F. The marginal damage cost, area under the marginal damage cost curve would be defined as the damage costs of pollution. So with a low level of pollution, this area would be very small. Here I define it as G. So it is very clear to say that the sum of G and F, the sum of the small triangle and this blue triangle, would be exactly greater than the sum of yellow and red area, right? So from those three examples, we can say the optimal level of pollution or the optimal level of abatement is achieved when the marginal damage cost is equal to marginal abatement cost. So here I have a question from the perspective of a producer, of pollution producer, of products producer. What are you willing to pay to abate the pollution if there is no government intervention? The correct answer is that no, there would be no willingness for them to abate any level of pollution, because from their perspective, they don't really care about the marginal damage cost, because the marginal damage cost is the cost to other people, is the cost to the ecosystem. Without government intervention, they don't really care about this part. They only care about their product profits, right? And without government intervention, they will only care about those lines. This line, the marginal abatement cost curve. When they abate nothing, their cost would be at this point would be almost zero. When they abate more, the marginal abatement cost would be much more for them. So from their perspective, there would be no willingness for them to pay to reduce the pollution without government intervention. So we already know that the efficient level of pollution can be achieved when marginal damage is equal to marginal abatement cost. How about from the analysis of cost and benefit? Can we still get the same answer by doing cost and benefit analysis? The answer is yes, we can, because we spent so much time in the last video to introduce the cost and benefit analysis. And in this video or in next videos, we will talk about the application of this analysis method. So first, to do this kind of analysis, we need to know which one represents the benefits, which one represents costs. Then we make a difference between the total benefits and the total costs. We want to maximize the difference, or in other words, we want to maximize the social surplus. And at that level, we can say the level is an efficient level, or the level is an optimal level of pollution. So from this pollution example, actually we define marginal damage cost as our marginal benefits curve, because when we reduce the damage to human, on the other hand, we can say we provide some benefit to human according to the reduced damage, right? So from this view, from cost and benefit analysis view, we can regard the marginal damage curve as marginal benefit curve. So the marginal abatement cost curve is still marginal cost curve, because there would be no benefit part related to the marginal abatement cost. So when we already know the marginal damage and the marginal abatement cost curve, we regard marginal damage as the marginal benefits of reducing emission, and we regard marginal abatement cost as the marginal costs of reducing emission. So from the method we introduced in the last videos, the social net benefit is maximized when marginal benefit is equal to marginal cost. Right? So this graph would be much easier to analyze this question. As we can see from this graph, the red curve represents the marginal abatement cost curve. The blue curve represents the marginal benefits from abatement. So the intersection of those two curves is our optimal level of pollution control. So we really need to make a difference between this graph, this pollution control graph, and this efficient level of pollution graph. So the difference between those graphs is the x-axis. So for this graph, the x-axis represents the quantity of pollution. But for the pollution control graph, the x-axis represents the quantity of pollution control. Can you see the difference? So from this graph, the downward sloping line is marginal benefits from abatement, or we can say the downward sloping line is the marginal damage curve, because marginal damage curve can be interpreted as the marginal benefits of pollution reduction. The upward sloping line is the marginal abatement cost curve, or we can say it's the marginal cost curve. But from this graph, everything is opposite. The downward sloping line becomes the marginal abatement cost curve. The upward sloping line represents marginal damage cost curve. Yes, so we really need to make the difference between those two graphs. Rather than when we have this kind of graph in your assignment, in your quiz, or in your exam, you really need to make sure what the x-axis represents. If it represents the quantity of pollution, then we are do this kind of analysis. If it represents the quantity of pollution control, then we are doing the cost and benefit analysis. So from the cost and benefit analysis, you should be very familiar with this kind of graph. The downward sloping line is marginal benefit. The upward sloping line is the marginal cost. The net benefit, the social net benefit, is maximized when MB is equal to MC, and the net benefit is this triangle. Enclosed by red line, green line, and the y-axis. So that's the cost and benefit analysis. So still, the optimal level of pollution control, or the optimal level of pollution, is the intersection of those two lines, of MB and MAC. And from this way, the optimal level of pollution is the intersection of MD and MAC. So we can say it doesn't matter which way you use to analyze this kind of question. If you do it correctly, you can always get the same answer. The optimal level of pollution reduction is when MAC equal to MB. And we can also say the optimal amount of pollution is achieved when MAC is equal to MD. Then I want to talk if there is any policy to achieve those levels, those optimal levels. Yes, there are. There are so many different kind of instruments or policies we can use. And in this video, we first introduce the quantity-based instruments, or we can say the command and control way to control the level of pollution, to respond to pollution. So we say this method is a quantity-based instrument because this method regulates the same amount of emission or production of pollution. So we often do this through several methods. First, we use emission standards. That means the government set legal limit for the amount of pollutant an individual source can emit. Also, we can say the government set the legal limit for the amount of pollution that a company or a factory can emit. Then, we can also do this through technology standard. When would you use this method? If the pollutant is highly dangerous to human health or highly dangerous to the ecosystem. For example, we can use command and control method to control the use of DDT. So it is a famous example in the US that the US government limits the use of DDT to 0. DDT was a synthetic chemical. It was widely used as a pesticide, and it is also a kind of stock pollutant because environment itself cannot absorb it. So it was used very popular during 1970s. U.S. used almost 18 million pounds per year. It harmed human health, harmed animals like birds, and also our ecosystem. So the U.S. government banned it in 1973 by EPA, but it is still used in Africa. Even though the command and control method is a very strict way, is a very effective way to control the human pollution, there would be so many problems with this method. For example, there would be high information costs and monitoring costs because it is not so easy to monitor each firm's action. Also, it would be difficult for us to decide the optimal level of pollution because command and control only looks at the cost part, not the benefits part. So if we want to get the optimal level, we need to compare the cost and the benefits. Then we need to maximize the difference between benefits and the cost, right? Also, like the graph, like this analysis. So we can say if firms they have different level of technology development, the cost for them for different firms to abate the pollution would be different. For firms with higher technology, the cost of the pollution abatement cost may be lower. But for firms with less level development of technology, the pollution abatement cost would be higher for them. So in the real life, firms may have different abatement costs. So if we set the same amount of quantity to abatement regardless of their cost curve, this method may be ineffective. And also, there would be no incentive for firms to innovate or to develop technology if they can reach the limits set by the government, or there will be no incentives for firms to find alternative way to reduce the pollution. So that's all about the command and control method. It is a very useful and straightforward method to control the pollution. But on the other hand, there would be some problems with this method in the real life. In the next video, we will talk about the price-based instruments.